I'm Hal Starr, and I'm going to talk about economics. What is economics? Why is it so important? And then I'm going to demonstrate why it's so important. Economics is a study of exchanges of goods and services at various stages of production under various degrees of government intervention. Economics incorporates valuable lessons from the past and present and fosters critical thinking skills. It doesn't dictate what to think or how to do something. It trains individuals in the art of thinking. When reading an article on an issue, I don't readily accept the author's arguments. Instead, I contemplate the information being reported, identify the underlying assumptions and evidence, and assess the potential negative or positive consequences of the proposed actions. As an example, a few years ago, Bill Gates published an analysis on LinkedIn in August of 2018. His article suggested that he had discovered that supply curves do not slope up for goods like software. Now, this wasn't a novel discovery. It is well understood in the Austrian School of Economics. Frank Shostak, for example, in a Mises article titled Reality Gets in the Way, The Trouble with Demand Curves, had discussed this 2 years earlier. This article, because I read this article, it allowed me or inspired me to code this problem that I created in my open math. The problem is quite long. I'm going to show you an abbreviated version of it. But on the left is the demand curve, and on the right is the revenue curve. The demand curve is assumed to be linear, and it's given by this equation. When the price is high, the quantity is low. When the price is low, the quantity is high. Another way to think about that is the first buyer is willing to pay just over $300 for this software. The 3,000th buyer, for whatever reason, is willing to only pay $20 for it. So as things get scarce, the price goes up demand curves. There are some assumptions in this model. Total cost of the operations of this fictional company is $216,610. Those costs are fixed because the marginal cost of an additional download is close to zero, which makes sense because the person downloading the 1,000th copy, that cost is the same as somebody downloading the next copy, the 1,001st copy. The difference in cost is close to zero. Now, to illustrate this model, we first label it completely. And then I put this table underneath the two graphs so we can calculate things in Excel. So in my class, students calculate these things in Excel. The first column is quantity. This is the price column. This is the elasticity column. And this is the revenue column. So if the company wants to sell 1,440 downloads, we plug that in the demand curve up here, and we get a price of 174. We're using this elasticity equation over here. We're substituting the values into it, 1 over the demand curve's slope, and we have a price quantity ratio here. The elasticity at this point would then be 1.21. The revenue can be found by multiplying the width of this orange rectangle by the height of the rectangle, 174 times 1,440. And that is the height of this revenue graph, $250,560. Now, if the company lowers its price to 159, lowers its price to 159 from 174, it'll sell a few more units. The elasticity falls to 1.00, and the revenue peaks at 252,810. So as we lower the price, the quantity falls along the demand curve, elasticity declines, revenue rises. But then notice we're at the peak of revenue. If we raise the price anymore to say $144 per download, the company does sell more units because the price is lower. The elasticity falls below 1 to 0.83. The revenue declines to 250,560. So the revenue rises and then falls. That begs the question, what is the optimal price? Based on the analysis above, you recommend that Cyberdyne charge $159. That's the price where revenues are maximized. And at this price, the supply curve is this red flat line at the price of $159. So this is the supply curve of the Bill Gates software model. It's not upward sloping. Now, according to this diagram, the supply demand meets at 1,590 downloads, which we found out in the table. Now, the revenues again are $252,810. That's the area of this box, right? The cost of this production is fixed because the marginal cost again are zero by assumption, by reality, 216,000. So the profit is 36,200. Now, because the slope of this curve at this point is zero, we say the marginal revenue is zero. At this price of 159, marginal revenue equals the marginal cost, which was zero, right? And profits are maximized. So in conclusion, Bill Gates' insight, although valid, wasn't novel. It is well known in non-mainstream economic schools of thinking, like the Austrian school. Thank you.